welcome to the Mobilize and Restore Center webinar series, and thanks to those of you who have continued on from the research talk. In this portion of the webinar, our speaker, Keenon Werling, will walk participants through a tutorial of uploading and processing motion capture data and provide best practices and troubleshooting tips when using AddBiomechanics. And again, we'll take more questions at the end of the tutorial. Again, use the Q&A panel and not the chat, and feel free to enter the questions during the talk as he's talking. With that, Keenan, go ahead and start the tutorial.
Okay, will do. Let me share my screen again. All right, so part 2, practical details. We're just going to do 3 things here. We're going to walk through processing some sample data, and then we're going to talk about IRBs and informed consent and a little starter pack we've put together for this. And then we're going to finish up by talking about tips and tricks for best results. So starting at the start, I should say that what I'm about to show you is an upgraded version of AddBiomechanics, which will be in production very soon, but is not out yet. I was really hoping to have it completely bulletproof and ready by the webinar. I think it will take at least another few days. But we will be sending out an email when it's ready, along with all of these instructions so that you can follow along. And this is all recorded, so you can come back and watch this later. So for now, be like this starfish and just let it wash over you. Okay. So we've prepared some sample data if you don't happen to have data already. If you do have data already, great. Let's use that instead. But you can go ahead and get sample data from this link. Okay. So let me show you a recording of the interface. And I recorded this so I can also talk over it at the same time. So when you log in, you're going to have a folder full of data. And to begin processing a new subject, you're going to create a subject, and then you're going to click into them. And it'll show you this form. And the form, in order to not be overwhelming, only shows you one field at a time, and then shows you a progress bar at the bottom as you begin filling things in. And hopefully everything is fairly self-explanatory. You're going to need the height and mass of your subject, the biological sex, if it's available, the age in years, if it's available. And then we're going to ask you to tag your data, at least with the unimpaired tag, if there's nothing more interesting to say about the subject. But there are other tags available. You can upload your OpenSim model, choose whether or not you're going to ask the model to try to fit the physics. You can choose to skip that if you want. If you choose to skip that, you don't get this option to solve for muscle activations, which uses an integration with the MoCo pipeline to do the solutions. We ask you the provenance of the data, whether you found it on the internet or collected it in a pilot study and it's a mess, or this is very high quality study data you're very confident in. If it's very high quality study data, we give you more processing cycles so that we can get you the highest quality results possible, but it'll be a little slower to return. We require subject consent, and then you can add a citation, and you can put whatever you want here. Please, please do not put any PII data in the citation. Don't say Keenon Werling's mocap data from 2020 if I'm the subject, unless your subject explicitly asked to be cited in the use of the data. And that last step there is to just hit the process button, and then it runs. And let me show you on the next recording what happens after you finish. So you go get a coffee, this runs for probably 30 minutes, and you get some results. And each of the segments of your trials now has a standalone visualizer page. These pages work on mobile, they're shareable links. You can post your results on Twitter if you like. You can change the playback speed. You can plot quantities interactively and scrub the plots together. Zoom in and out. We've got layers for different quantities if you want to choose to show or hide different amounts. And that's pretty much it. I can't wait for you guys to get your hands on this latest version here. I should say that the results here are unsmoothed, and you can go ahead and do smoothing after the fact. And we're also working on adding a cutoff frequency if you want to specify that in advance so that you can just use the visualizer directly without needing to maybe download the results. All right, so let me say, this is all arriving in production very soon, hopefully days, at worst a week or two. All right, so IRBs and an informed consent starter pack. It's incredibly, incredibly important that you get informed consent before uploading data. Data uploads should always be done ethically. When you come to the subject consent element of the user interface, there is a little explainer below it, and there's also some example text down here, which is cut off in the screenshot with some example text for a consent form and example text for an IRB amendment. And there's also a web page at addbiomechanics.org under data sharing mission. There's an explanation of why we do data sharing, and there's also a hopefully a tremendous number of resources, including things like, what do I say to IT to let me upload my data to this this tool, and what do we include in the IRB and things like that. We've tried to make this complete, but every bureaucracy is slightly different. If you come across questions where you need resources that we don't yet provide, please post them to our forums, and we would be more than happy to help. We want to make it as easy as possible for everyone to share if you are able to. Okay, so that's it for IRBs and informed consent. I think at the end of the day, hopefully it's not too hard to do. So let's go to tips and tricks. And I should say, we have worked really, really hard, and we continue to iterate. Our goal is that you really don't need to worry about the tips. We want the tool to remind you if it senses that anything is wrong, and also for the user interface to guide you through making sure that you more or less do everything right as you go. So I'll say in tip number one, you don't need static trials. You can collect them if you want, but they don't add very much information on top of the functional joint center finding. So you don't have to upload them. Tip number two, and this is actually very important. If you're going to use a custom OpenSim model, specifying which markers are bony landmarks and which markers are just anywhere on the subject, or at least anywhere on the segment, which we call tracking markers, is really important. So we use the fixed flag on the markers to make this distinction between anatomical markers, things that are placed on bony landmarks, and fixed is false for tracking markers, things that are like triads that are just taped to the segment. Fixed is a tiny bit of a misnomer and is coming over from existing OpenSim backwards compatibility. If you have an anatomical marker, it is allowed to move a tiny bit in the optimization. It is just heavily, heavily penalized for doing so. Tracking markers are allowed to move a lot along a segment in order to fit the data without needing to rescale the bones and do other things. So this has a huge impact on the quality of your results if you're using custom OpenSim models, so pay attention to this. Okay, tip number three, please cite yourself. You can leave your citation empty if you want. I'd recommend that you include how you want to be cited so that people can send you citations, increase the impact of your work. I would also say mark your pilot tests. If you want to just experiment with the tool, please absolutely do so. And just say, hey, we're just experimenting. We will return you results a bit faster. And also it ensures that any data you upload undergoes a much higher scrutiny bar before inclusion in a public data set. Yeah, thank you. And then tagging. So tagging is important for the community if we want to use this data set to do things beyond kind of unsupervised prediction on things like motion and joint torques. So if we want to actually be able to run ML models about Parkinson's or about athletics or about whatever the task is, it's important that we be able to filter the data for people who are in that subject population and maybe people who have been tagged in ways that are useful for whatever the task is. So I know pretty much any tool you use, if there's a tagging interface, most people will ignore it. I'm pleading with you to please spend the extra 5 seconds to label your data. It will help the community tremendously. And then I'll say a new feature is that you can now solve muscle activations with MoCo. OpenSim MoCo is a wonderful software package co-authored by Nick Bianco, who's also a co-author on AddBiomechanics. And we now integrate, thanks to Nick, with MoCo. And if you hit solve for muscles, we will automatically generate you a MoCo simulation, solve for all of your muscle activations over time, and even generate you your own starter Python code where you can rerun the simulation and tweak the simulation on your own to get best results. So this is a highly recommended time saver. And then the last tip is contact us on the forums. We have forums. We try to direct Q&A over there so that other people can benefit from using Google to find the answers to questions rather than having to actually reach out to us via email. And with that, I'm going to say end of part 2. So part 2 is a little quicker than part 1, but now we have plenty of time for questions. So
yeah, definitely. And we have several to go through, but it sounds great. So yeah, we will switch over to the Q&A. And actually, we can start with some that came in a little earlier as well, just work our way through. So first question is from Aaron Chang. How does AddBiomechanics accommodate data captured from people with functional disabilities? Can it be used if the full body isn't being measured? So if you're doing an upper extremity task at a table. And also, can this be used on motion capture data from active LED markers?
So let me go first and second. For people with functional disabilities, hopefully, yes, it will work. But I will say the one important feature that helps make the results so high quality is that we use a statistical anthropometric prior over the covariance of different attributes of your body. So the length of different bones and how they covary with others. And that ends up being just a big multivariate Gaussian that is conditioned on the data you punch into the form with height and mass and biological sex, if it's available. That data, the most detailed data set that I have found for that is from the US military and is called the Answer 2 data set. And the US military doesn't have a lot of people in it with functional disabilities. And so it also doesn't have a lot of children, which is an important other limitation. I am working on including a feature to disable the prior if you know that your subject's anthropometry is going to fall way out of mean for good reasons. Your mileage may vary in terms of the quality of results that come back, depending on how many markers you used and how much range of motion you actually saw in the trial, because it doesn't have as many other statistics to guide the solution. So you may get things like funny sized pelvises, which is never ideal. So the answer is maybe. On non-full body, similar answer, because we use this anthropometric prior, we assume there's a height to the subject, and that height is measured from the feet to the top of the head. Again, we can turn that off for you. Your mileage may vary. Like, these are important constraints that we're turning off. If you have access to data sets with anthropometry from people who are have different sorts of skeletal conditions, and also from children, that would be incredibly helpful for making the tool work well. So reach out to us. I have not yet found any good data sets. On the LED optical markers, as long as they produce traces of 3D point clouds, like if you're getting C3D files out of your tool, it should work fine. Yeah, I'd love to try it. Okay.
Yeah, for sure. Next question, and I guess there are several questions about other data sources, basically. So is it possible to publish accompanying data? The question was from Marcus Gambits. Is it possible to publish accompanying data, for example, IMU EMG data via AddBiomechanics? But also the other part of that question was about, like, if you have LED marker motion capture, if you have motion capture, say from OpenCap or whatever motion software.
So the The limitation here is more that I have not figured out an elegant user interface to do this, and less that it is technically difficult. For obvious reasons, I am also really interested in publishing exoskeleton joint torques along with data. And I want to find ways to annotate OpenSim models with exoskeleton data and also upload exoskeleton joint torques in sensible formats. When I have done my user studies to try to figure out the formats that this data comes in, often it comes in MATLAB .mats, and that can be messy to work with in an elegant, easy to use way. So we're working on it. Yeah, it's on the roadmap. I'd love to do it as soon as possible.
And I would say also, we do have SimTK as another option for if you want to create a project page on there and share data that is not going into AddBiomechanics. That's an easy way to do it publicly.
Yeah, and I would add to that for things like your spreadsheets for your kind of summary data. If you're doing that hamstring to self-selected running speed study, I used it as an example. That's probably never going to go on AddBiomechanics. So linking to AddBiomechanics from a kind of mothership of data is a good thing to do. And SimTK is an excellent place to put that in addition to your journal.
Definitely.
So jump in for it 1 second. I think the other part of it that folks are really curious about is, can you use these other data sources about movement in AddBiomechanics? So the marker outputs
EMG
from
and
AddBiomechanics or other outputs from markerless motion capture or IMU data. Can you have all the benefits of AddBiomechanics if you're using those kinds of data collection?
So currently, we don't have an AddBiomechanics equivalent if you're going from markerless or if you're going from IMUs. I would point you towards OpenCap for a markerless system that's kind of like AddBiomechanics. If you have 2 iPhones and you want to collect pretty high quality musculoskeletal models that are auto-scaled for you, check out this other tool that comes out of the lab called OpenCap. It's awesome. For IMUs, there are ongoing active research projects to do this, to integrate the information in with AddBiomechanics and also maybe to do the motion capture directly from there, but we don't have anything for you yet. Thanks, Jen. Excellent question.
Thanks, Jen. Yeah. Another good question that just came in, it's from Adrian Rivadula. If you have a large data set, do I still need to upload one by one? Is there a way to automate the process?
Yes, so there is a way to automate the process. We have a command line interface. I didn't show it today because I didn't want to get too in the weeds, but there is a GitHub repo for AddBiomechanics. On there is a folder called CLI, which has all the instructions for how to install the command line interface and use it. There is a way to upload folders in bulk. There's even a way to download data in bulk from AddBiomechanics if you want to. There's also tools for viewing the data locally, analyzing it, filtering it, standardizing. So hopefully that's a really handy tool. Maybe we should honestly have another webinar about that for a select group of people who love their command line.
Yeah, for sure. Another question from Sam Hamner. I think to touch on the tags. So in terms of, are there consistent tags to choose from? And, I think that's something we've thought about, and maybe we could talk about the process of if you don't see a tag that you want to use. Yeah. You
want to riff on that, Matt? I know you may have even thought about that more than I have.
No, that's all right. I mean, to the question is, basically we have set an initial set of metadata tags that we have started with, and we do want to make them consistent, as he's mentioning, so that if we are trying to combine data sets, that we do have a consistent set, so that there's not various forms of, say, running or different types of tags. But if we are interested in adding more tags, we do have the forum, and we do have means for potentially adding those down the road. And so if you don't see the ones you want to use, then basically reach out and contact us, and we can start adding some more tags.
Yeah. The only thing I would add to that is the reason we don't let you add, well, there are 2 reasons we don't let you add your own tags custom directly in the web interface, because that would be awfully convenient. One is we're worried about duplicate tags, and 2 is we're worried about PII leaking into the tag set. And so reach out to us and we'll we'll get things added pretty quick.
Yeah. And maybe, so next question is from Teresa McGurk. In addition to tagging the subject, so we talked about subject level tags, but there are trial level tags as well. So her question was about, is there a method for, like, if you're trying to tag a subject walking at a self-selected speed on the treadmill, or walking at a self-selected pace over ground or something like that? Are there options for those?
Yes, there are trial level tags. In fact, in the current interface that's up live in production right now, we have trial level tagging. That is one of the features that I have not finished yet, which is part of why the new interface is not yet live in production, but will be soon. So by the time you see it, that will be there. So not to worry.
Question about models. I think we can touch on that a little bit as well, in terms of if you're not using the out of the box models that we have in this, and you want to use a custom marker set. So the question is from Varun Joshi. Are there limits to the complexity of the models that AddBiomechanics can handle? He's had some trouble with multi-segment foot scaling in particular.
Multi-segment foot scaling is hard because of the functional joint center approach. So the problem is there isn't a lot of range of motion between the segments of the feet in most trials, and the marker data also tends to, because the distances are so small, any noise in your optical motion capture system will be amplified by dividing by pretty small numbers. So yeah, that's challenging. I mean, we tend to use we tend to apply our ground reaction forces in the experiments we've been running with AddBiomechanics at the calcaneas, and then use inverse dynamics going up the chain as very reliable. Inverse dynamics within the foot, I think for things like that, you probably want to turn to something like MoCo, where you have contact spheres and you're actually doing a more sophisticated job of simulating the contact and optimizing that. So I'd recommend using the MoCo flag, generating a MoCo simulation, and then downloading it and tweaking it until you're satisfied with the results.
Another question, maybe we can touch on the different motion types that you could potentially input into AddBiomechanics. So the question is from Lushank Shampa Harkar, sorry. Is this only for level ground walking? They have data related to walking up a slope or downstairs cases. So would it be useful in those cases? And maybe if you want to touch on the variety of movement tasks you could potentially put into AddBiomechanics.
Yeah, so it will totally work on slopes and drop jumps and stairs and all sorts of things. The kinematics, like the pure motion, so just optimizing the first 3 steps of the pipeline until you get to accurate bone scales and accurate joint angles and accurate marker offsets within the bones, but not necessarily working on the physics. That will all work pretty much all the time, no worries. The thing you have to get right if you're going to do physics on a sloped treadmill or on a instrumented set of stairs or on a drop jump, is you need to make sure the center of pressure information is correct spatially. So you need to actually have it, the center of pressure can't be moving along the flat ground if your treadmill is rotated. The center of pressure information has to be moving spatially with the treadmill. I imagine your system probably does this for you already automatically, but it's just something to watch out for. If you give it inaccurate center pressure information, assuming a flat surface, it's gonna choke. But otherwise, everything should work.
Great. There was a question earlier that came in. It was answered by our team, but I think it's worth bringing up, and it's related to the movement task as well. In terms of cropping your data to clean strides for AddBiomechanics, do you have tips and tricks around that? Do we have tools for segmenting the data?
Yes. So this was actually one of the motivations for the big upgrade that is just about to land, is that previously our approach to cropping, so say you collected a 15-minute trial and you have a motion capture space where you've got only a couple of force plates and you have the subject walking in circles, and occasionally they will have strides over the force plates and most of the time they will not. Previously, you either had to manually clip this data yourself into segments with physics and segments without physics, and then upload them all individually, Or you could upload the whole 15-minute trial, and the system would automatically, if you asked it to solve for physics, find one section with physics in it and trim everything else off. And so you would go from your 15-minute clip to like 4 seconds of data, which was a terrible solution. So what we've done now in the new version that will be hitting production very soon is we automatically segment the trials for you into multiple sections based on where the ground reaction force matches the center of mass acceleration, and then places where the ground reaction force is obviously absent because it deviates from center of mass acceleration for a long time. And so your 15-minute trial will be sliced up into a bunch of segments, some of which have forces detected and some of which do not. And that should happen for you automatically. I will say our heuristics for detecting short periods where you do not have forces are not perfect. So for example, if you have a very short trial where you're jumping off a box onto a force plate to do a drop jump, and you did not instrument the box, and you have just a fraction of a second of standing on the box before you begin jumping, you may see some motion artifacts in that initial phase where AddBiomechanics does not detect that fraction of a second doesn't have forces in it. And in those cases, it can be helpful to either manually trim that section off or mark it in the tool that's a section that needs to be a split point where you have no forces for a portion of the time.
Great. And there maybe, and this can maybe be the last question actually, or just the topic in general, but I think it may be worth just touching on, there were some questions about what the output of AddBiomechanics is, and we're letting them know that it is in OpenSim format. So maybe just real quick, what input files can people put in? You know, what
inputs and outputs.
Yeah, yes. And what outputs do we have?
Excellent question. Okay, so as inputs, you can have C3D files for your motion, and your C3D files can come bundled with forces or not. Or if you prefer to live in OpenSim format land, you can have TRC files for your marker data and mode files for your ground reaction forces. So if you have a pipeline that you like to use that pre-processes your data, I'm not sure I recommend pre-processing your data because we do a fair amount of error checking for you on your data, but you can, and then you can upload TRCs and modes. And actually the demo data we have for you has TRCs and modes in it, so you can see that the interface auto splits when you upload a TRC. It'll then ask you for the corresponding mode file for the ground reaction forces if you want to include physics in that trial. If you have a C3D, it'll auto detect and figure everything out for you. Obviously, the models are OpenSim models to start with. So your generic base model that you're scaling for your subject, you either select one of our pre-provided OpenSim models or you upload your own. Output formats are either a zip ball full of OpenSim results, which you can download, which it sounds like people have already been mentioning in the chat, or we provide a binary format that's kind of like C3D, that bundles all of the C3D information in addition to all of the IK solutions, all of the ID solutions if they're available, and the scaled model for machine learning purposes. So if you want a nice condensed file that loads efficiently that you can have hundreds of gigabytes of and use to train your PyTorch model, that can be a good option as well. And those both are included in our big releases.
Great. All right. Well, unfortunately, we are out of time. And so thank you again, Keenan, for a great talk and tutorial. And thank you to everyone and the great questions that have come in.
All right.
Please be sure to click the link will appear at the conclusion of the webinar and take our survey. That'll help us improve the webinar series and choose upcoming topics. This webinar series is supported by the 2 grants from the NIH, including the grants that support our Mobilize Center and the Restore Center. We're grateful for the support, which allows us to run these webinars and other events. Thank you again for everyone for participating. We hope you'll continue to stay involved with our centers, and we will see you in a future webinar. Have a great day.
Okay, thanks everyone.